Hi folks, welcome to this video where we're going to take a look at the Venn diagrams and set operations, my open math homework. Now, again, some of these come with video, so I won't go through the whole example, but I think I really want to make sure that we know some notation and what those phrases mean, okay? So let's take a look at this first question. So they show you a Venn diagram, okay? Now, a Venn diagram is really just when you have some circles and you're thinking about how they overlap with each other, if they do, and that's one way of showing how some sets share things with other sets, okay? And so in this question, we're really trying to figure out which one is on the inside, okay? So keep in mind from the last video, and let me go ahead and write over here, okay? So in the last video, we talked about proper subsets. And so we use notation where we said like A is a proper subset of B, or maybe we had B is a proper subset of A. And in this first way of writing it, it means that all the things in set A are also in set B. Okay, so all the things that are in A are also in set B. But when we switch the order, it really means it the other way around, that all the things in set B are also in set A. Okay? And so I'll let you think about how that might apply to this problem, but I just wanted to remind us of what a proper subset means, okay? This is a good time to pause the video before I erase what I have on the screen. Okay, so let's move on to some of the other examples, all right? Looks like question 2 is really similar to question 1, so I'll leave that for you, okay? Now, something like this might feel very overwhelming because we have just sort of a lot of letters going on, okay? And what I want to do is kind of just talk about this diagram a little bit and see how we can make sense of all the letters that's happening, okay? So what we have here is we have a set U, okay? So let me write that, set U. Now set U has all of the little letters that are inside this box. So I could write it as a squiggly. I notice there's an A, B, C, D, E, F, G, H, I, and J. Okay? So those are all of the elements in set U. Now, here are the ones that are inside set A, all right? So we have H, D, A, I, B, and F. But I could also look at all the ones that are in set B, okay? So set B would be over here. I have G, C, F, and B. And then I have some items that are in neither. And so if I look at this, I've got J and E kind of hanging out. J and E are not in A and B, but we do have most of the elements are either in A or in B. Now, we also have a really special pair of elements in here that we circled with both the red and the blue. Okay, so if you look at this color coding, you'll notice that B and F we circled in red and blue. That means that B and F are in both set A and set B. Okay, that's kind of how you read a Venn diagram. Now, this is a good moment to pause if you want, all right, because I'm going to erase this and then let's look at the questions that we have below. All right. So question A says, list the elements in U that are in A and in B, okay? So we want to think about which elements are in A and B. Now, those would be the ones where we circled in the blue and the red, okay? And so if you remember, that was B and F, okay? Now, how many elements are there? Well, we count them. There's B, that's one, F, that's the second one. So there are two elements in both A and B, all right? So when we say A and B, we mean both A and B. All right, that would be the key word here. All right, now I'm going to go ahead and scroll down a little bit. So I'm going to delete this. Oops. Okay, so let's take a look at some of the other questions here. All right, list the elements of U that are in A or B. Okay, so A or B means those are the ones we circled in red or blue or both of them. Okay. And so that would be A, D, I, H, F, or B, F, G, and C. So all of those, and I won't write them all out here, but all of those are in A or B. And if we count how many of those we have 1, 2, 3, 4, 5, 6, 7, 8. So we would say that there are 8 elements in A or B. Okay. Now, I had also said, let's take a look at some of the ones that are in neither. And we might notice here that J and E, those are outside of A and B. So J and E would be the ones that are in neither one of those, okay? But this question says, list the elements of U that are not in A. So let me go ahead and clear that. Let's see the ones that are not in A, okay? So that means I don't want this one because that's an A. I don't want this one because that's an A. So I can cross out all the ones that are in A, and then the ones that are left, G, C, J, and E, those are what I'm going to put here. And there's 4 of those, so there are 4 elements not in A. Okay. All right, let me clear this. And let's take a look at the last part. It says list the elements that are in A but not in B. All right, let's go through and see which ones are in A. So this one is in A, this one is in A, this one is in A, this one is in A. But the B and the F, those are also in B. So I would only want to list A, D, H, and I, and there are 4 of those elements. Okay. All right, let me clear those. Now, we get a lot of questions that are kind of like this, okay? So we're looking at different ways of counting and seeing how many are in each one, all right? And so let's take a look at question number 6, okay? Question number 6. So for question number 6, we have a Venn diagram, and it tells us how many things are in A and B and C, okay? And so it doesn't list them all, it just tells us how many we have. So if we look at how many are in set A, that would mean everything inside this green circle. And so I would take 8 plus 12 plus 5 plus 4 plus 2, and I would get 27. That would mean that there are 27 elements in A. Okay. Now let's skip to the one that says how many elements are in A and B. So if I want A and B, I need everything in that green circle, but then I also need the ones in B. So I'm going to add a 5 and a 4 to that. And if I think about the ones that are in A and B, all right, I don't want the ones only in B. I don't want the ones only in A. I'm just going to take the ones that are in both of them, and 12 plus 5 gives me 17. Okay, now let me erase some of this. It's getting kind of messy. And let's switch colors. Okay, so how many elements are not in C? So I don't want the 9 because 9 of them are in C. The 2, the 5, and the 4, those are still in C, okay? So instead, what I have to do is find the ones that are not in C. So we've got 8 plus 12 plus 5 plus, don't forget this 16 hanging out here. And then if we add those all together, 8 plus 12 plus 5 plus 16, that gives us 41. All right. Let me go ahead and erase this so we can take a look at the last question here. Okay, so the question says how many elements are in A and C, but not in B? Okay, so where are the ones in A and C? If I look at where the overlap is, 2 and 5. There's 2 elements that are in A and C. There's 5 elements that are in A, B, and C. But I don't want the ones in B, so really I just have 2 elements in A and C, but not B. Okay, so I hope this was helpful. Let me go ahead and clear out those drawings. But I hope this was helpful. Let me know if you have any questions, and I'll talk to you soon.